Kinetic energy. So we said the ability to do work is energy. Now we will see what is kinetic energy. This is one form of energy. This happens whenever there is a body which is in motion. Let's say, for example, a moving cricket ball. There are the cricket stumps, and when the moving cricket ball comes and hits the stumps, one of them will fall off based on where it comes and hits. Let's say it's coming fast and hits the stumps. What happened actually? The ball came and hit the stumps, and the stumps moved away. So this is a moving ball. The moving ball did the work of moving the place of the stump. What it did? It has done the work of pushing back the stumps. And the stumps gained the energy from this work. So whenever there is an energy of a body due to its motion, then it is called kinetic energy. It means a moving body like this cricket ball is capable of doing work. In this case, it has pushed the stumps. That is the work it has done. And hence we say this moving ball possessed energy. So that energy is called kinetic energy. So we say the energy of a body due to its motion is called kinetic energy. So the ball is possessing an energy which is kinetic energy because it is possessing this energy because of its motion. Because of its fast moving, it hit the stumps and the stumps got pushed. For example, a moving hammer drives a nail into wood. We have a hammer we use it for hitting the nail into the wood. Because the hammer is moving, we are able to put the nail into the wood. If the hammer does not move, what will happen? No work will be done. And a moving bullet. When you fire a gun, the bullet comes out of the gun and it hits the target. The sheer motion of that bullet, the sheer speed of that bullet with which it is moving, gives it that energy to do the work of hitting the target. In fact, we say every object around us is moving, possesses kinetic energy. Any object in this universe which is moving possesses kinetic energy. In other words, we also can say that every object around us which has a speed possesses kinetic energy, because any object that moves, that is in motion, does have a speed. So when it has a speed, then it possesses kinetic energy. For example, a person who is running, a runner, since he is in motion and he is running with certain speed, and he possesses kinetic energy. Or a running motorcycle, or a running car, or a falling stone, a stone falling from a height, it possesses a kinetic energy. What happens when a moving body is brought to rest? What happens to this energy? The kinetic energy is lost because it is no more in motion. It is brought to rest, means the body is stopped. The kinetic energy is lost. How? It is being used up to do the work in overcoming the resistance of the opposing force. In order to come to a stop, this energy gets lost because it has to overcome the resistance of the opposing force, which is making it stop. Having understood this, let us derive a formula for kinetic energy. So before we start on the formula for kinetic energy, we will see the principle behind it. The kinetic energy of a moving body is measured by the amount of work it can do before coming to rest. It means basically we are trying to derive kinetic energy from the formula of work. We know how the work is measured, and using that we can find what is kinetic energy. Let us take a ball which is at a position A, and the mass of the ball is m, and it is moving with a velocity v. Now it has entered into a medium of air, and it has travelled inside in the air for certain distance, let's say s, and it had come to a stop. When it came to a stop, obviously the velocity of the ball will be 0. So let's call this velocity as capital V. This velocity is 0. Why? Because it has stopped. Now let us find out what is the work that's been done by this ball of mass m in travelling the distance s. Is given as force into distance, that is F into S. Now the force here is mass into acceleration. Now let us see whether we can equate this work done with the kinetic energy. At position B, let us say this is a position B. At position B, the ball, after travelling a distance of s with a velocity of v, stopped. Since the body is at rest at B, it has no motion, and hence there is no kinetic energy at B. So what happened at B? No motion, so no kinetic energy. What does it mean? That all the kinetic energy of the body has been used up in doing the work. What is that work it has done? Traveling a distance of s. So the kinetic energy must be the work done. So we will say this kind of work done is nothing but the kinetic energy. So this work done is equal to kinetic energy, because all the kinetic energy of the body has been used up in doing the work. Since kinetic energy of the body is used up in doing the work. So now we say, therefore, kinetic energy is equal to W, which is F into S. This is the first equation. Now we said the body has an initial velocity of V and final velocity, which is capital V, and the distance it has travelled is S. Distance covered by the object before it came to stop is S. Now we know from the law of equation of motion, V square minus U square is equal to 2AS. If we use this, in this case V is the final velocity, which is capital V square, minus U is the initial velocity, which is small v square, is equal to 2AS. Now what happens to A? The body has come to rest because of the opposing force. So the velocity constantly retarded. In the example that is shown, the velocity of the body constantly retarded. Since velocity changed from velocity v to 0 since the body has stopped. So the acceleration here is minus a. So applying this here, we get v square minus v square is minus 2as. Now here v is capital V, which is the final velocity, and the body has stopped. It is 0. V is 0 since the body stopped. So this becomes v square is equal to 2as because the negative signs will go off. Capital V is 0. This is the second equation. Now we know the first equation says W is F into S, and where F is mass into acceleration. Now we will put, instead of acceleration, m into v square by 2s. Why? From this equation, we say A is equal to v square s. So on substituting 3 in 1, we get W is equal to, which is a kinetic energy, F is m into v square by 2s into s. Now s gets cancelled. We get mv square by 2. So we say kinetic energy is half mv square, where m is mass of the body and v is velocity of the body. Thus, a body of mass m moving with the velocity v possesses a kinetic energy of half mv square. And the unit for this is joules. From this equation, we say that a body of mass m moving with a velocity v has the capacity of doing work equal to half mv square before it stops.